Let me share my screen. Okay, yeah, so we have a new release today. Stabilizes multiple features. This includes the change of inflation to time-based rather than block-based. So that's exciting. And yeah, so for today, I want to discuss how we want to reshard the state. The idea is that we want to enable sharding kind of soonish, maybe in several months, once the necessary work are completed. And to make that happen, one of the things we need to do is we need to reshard the current state into some number of shards, the number being larger than 1. So we want to discuss how we want to do that. Previously, there have been some discussions around this. And I think we kind of, what we agreed on is we can reshard based on kind of top level account for now, and then maybe figure out other ways to reshard the state in the future if we decide to go with some other approach. And actually, yeah, I had a discussion with Alex last week. We might want to. So basically, when we enable sharding, we want to. So one suggestion is that we want to only shard out the Aurora account, so that it will make. So every other account will stay in the same shard, and the Aurora will go to a different shard. This is to make sure the system doesn't get overloaded by the use of EVM. And yeah, maybe we kind of first discuss whether that's like reasonable approach. Alex, did you want to say something?
So the only thing I like about this approach compared to others is that if we reshard EVM into a separate shard and keep all other accounts in the same shard for now, then it doesn't it doesn't make the follow-up resharding when we reshard into multiple shards significantly more complex than resharding from a single shard, because it is still like presuming that Aurora is to stay in a shard of its own. The follow-up resharding will be effectively resharding the non-Aurora shard into multiple, so it is still effectively resharding one into several. So that's a benefit.
Yeah, so basically the benefit is that we don't touch the state much. We only separate out the Aurora account, and yeah, that would leave us with a lot of possibilities as to how we want to reshard in the future. Yeah, does anyone else have any concerns or suggestions on this approach?
No, this looks fine. Like for the short term and the long term, I thought about like some approaches, like for example, sharding in the contiguous ranges of accounts, or if sorted by account ID. This could be done efficiently if we have if we use like some sorted tree structures to represent the state, then it is possible to efficiently cut the state into pieces, into contiguous pieces. But currently, I think we use multiple different prefixes for different parts of the state. So it's the state that corresponds to a single account is not a contiguous range of keys in the state. So, but still, I think making a single account into a separate shard, like total account, is like a simple version of what we are going to have in the future. We can split in some way so that no matter how many accounts are using a lot of gas, we can split them.
So basically you want some like BST, right? Or like balanced.
Well, we were already discussing sorts of balanced tree for different reasons. I think the current tri-E can also be split efficiently. So like an O of depth, if we want to have some range of keys like separated from everything else. But one of the difficulties is, I think, the current state is not contiguous, like the state that is created with a single account doesn't occupy a contiguous set of keys, which complicates splitting it. And so if we can maybe do is like one-off change, like you are proposing to separate Aurora account, but if we are going to have some sort of automatic resharding, which we want to have eventually, then we may want to also change the state format to make it more efficient.
Okay. Yeah, maybe let's discuss this. Discuss what Evgeny proposed another time. So for now, let's maybe think about how we. So basically, if we're fine with the approach we're taking now in terms of how we want the shard to be, of how on the kind of account level want to split the state. Maybe we can discuss how exactly that's going to be done. In terms of the actual implementation, I think I kind of proposed some idea. Basically, the idea is that, okay, maybe we should get whiteboard or something. Yeah, so let's see. I'll just use this. So this. So this is, it's actually a bad way to draw this. So basically I want to say this is epoch T. This is epoch T plus 1. T plus 2. It's not blocks, these are epochs. So at the end of, let's say at the end of epoch T, we decide that in epoch T plus 2, we want to reshard the state. So what we do is that in epoch T plus 1, this is pretty much for like a more general purpose. Let's say we want to reshard. Okay, yeah. So let's say we want to reshard some shard. In our case, could be the only shard we have into two different shards for simplicity. And so what happens in epoch T plus 1 is that the validator of that shard would start to construct simultaneously two states. And so we can do this using the approach proposed by Evgeny. Essentially, we kind of start to maintain two states, and we kind of move from
so this would be essentially three states. So it will be a state of the previous state, which is one state corresponds to one shard, and two new states that correspond to two new shards, like one state for one shard and one state for another shard. And then when you move the entries, you are moving them into the one of the new states that corresponds to the shard where this part of the state is going to get.
That's a good point. Yes. Yeah, it's actually 3. Yeah, I was thinking that if you have 2, you can actually look up. Yeah, but that's actually a problem with lookup. Yeah. Okay. Yeah. So maybe we need 3 states. But anyway, so other validator for epoch t+2, who is going to validate one of the 2 new shards, what they will do is that they will still sync in epoch t+1 the state of the current shard, and then once they're done with that syncing in epoch t+1, they will do the same process as other validators would do. It's basically they would start after they're done with syncing that state, they would start splitting the state, and then that would ensure that by the start of epoch t+2, they would have the state for whichever shard they need to validate. Of course, they will also have some other states that they don't need, but I suppose that's fine. They don't need a state, so they would just have it. So that's kind of the idea.
I think that if a validator for epoch t+2, then during epoch t+1, they only need to sync the. Well, I think maybe they need to sync the new state for the shard, which is empty at the beginning of the epoch t+1, and then it gets progressively filled.
But you need to apply blocks, so you actually need a state to actually construct.
If the validator for epoch t+2, they don't need to apply blocks in epoch t+1. Why would they need
to? No. But my point is that you need the state, right? So at the end of epoch t+1, what you need is the state that for some.
So is it? Maybe I don't know how syncing works well. I think syncing also currently doesn't work properly because we don't have sharding. So I think the idea was to have some sort of. So is it correct that we want syncing to work like during epoch t+1, a validator syncs some state of the shard and then begins applying blocks on top of it? Well, then they will actually have to sync the entire chunk, the entire shard before split, because
that's what I'm saying. Yeah, you sync the original shard. Yes.
So they sync and then track the original shard. But then they discard part of it when the epoch starts.
Yeah. That's the plan. Yeah, that's basically what I was describing. Yes. And also the mechanism of syncing the state that you need to track is already built. So basically that we don't need to build. That's already there. So what we need is in this process is like after you're done syncing with the old one, you need to start splitting the state. So that at the beginning of epoch t+2, you would have the state to apply chunks.
Yes, but that's the same what regular validators will do. So basically, the same code can be used for this.
Yeah. Okay. What do other people think?
So I think I missed some important part. So as the state is being split, and I see that makes sense.
Okay.
You effectively, so let me just repeat what you're suggesting. So you're suggesting at the beginning of the epoch, we start splitting the state, right? Let's say it takes 100 blocks, right? And after 100 blocks, we're effectively running the catch-up procedure, right, that we have. I see.
Well, no, for the, it depends on like which one. So yeah, so for the people who run catch up, they first run catch up, then they split the state, because they cannot split before you run catch up, you don't have the new state. You cannot sync into the new state because it's not built yet. So you first need to sync the state of the current shard.
So let's go through it again. So at the beginning of t+1, oh wait, at the beginning of t is then we start splitting the state, right?
Beginning of t+1.
Or beginning of t+1. So I'm a validator, right?
Okay, let me share this this whiteboard so you can maybe write the stuff down if you.
Okay. Okay, let's see. Okay, so I'm a validator. I'm here, right? I have my monolithic state. Well, let's use some other color.
We use rectangle for everything. No?
Well, the state is a green rectangle now. So this is my monolithic state. It's some sort of a tree, right?
Yeah.
I want to get into two states, or one of them is everything, and one of them is Aurora, right? So that will take me some time, right? So there's certain procedure that I'm invoking at this point, right? So the moment this epoch starts, right? The moment
that is correct.
Starts, I'm invoking some procedure, which will take me some time. So this is the time it took me. At the end of this time frame, I have, well, first, so at the end of this time frame, I have my new state, which, thanks to the persistent data structure, has changed in the meantime, right? So this is what I have for the new state. So blue one is this point.
In the end, you have two states corresponding to two. So one new state for Aurora and one new state for everything else. And you have a previous state which is empty at this point. So at some point, I think at the end of the epoch, you can discard it.
Right, but then.
No, but that doesn't work. You still need to maintain the old state for this epoch because the block.
Yes. Yeah. But what do I do at this point?
I think in my approach, when you transition the state, you're actually moving elements from the old state to the new state. So when you are done, the old state becomes emptier.
But in your approach, the system needs to be aware, right? Like effectively, you look at abstraction in your approach, because in your approach, as we apply the block, we need to know that the state is being transitioned, right?
Well, we actually have some sort of abstraction layer on top of state. So when the runtime needs to read something from the state, it tries to read from both from the new state and from the old state. But this is kind of a separate layer on top of storage.
This is more complex, right? Because then you need to make sure everyone do the transition at the same time. Otherwise, the state rules probably don't match.
Yes, everyone is doing it at the same time. So it's the exact procedure is part of the protocol. So everyone is doing it in the same way.
But what about the approach where I suggest basically you in this epoch you still maintain the old state and then you also construct the new state at the same time, and when you do like any updates, you actually update both. And then
Bowen, what happens here? Like once, let's go through Bowen's approach.
It can work now because we don't have challenges yet, but my approach actually, as I wrote in the discussion on GitHub, so the Bowen's approach doesn't work with challenges because you can't challenge the moment when the old state is replaced with the new state. So if at this point the new state root is incorrect, you may not be able to construct a small challenge to demonstrate this. And with my approach, when the elements are working at some rate, like a few at a time, with this approach, you can construct challenge for every step.
Well, I don't.
But you're looking into the future for like for the time when we have dynamic resharding, right? For dynamic resharding, well, I don't want to discuss it too deeply, but there we have significantly more opportunities. Like one natural one is, I don't know if you guys see what I'm doing. Let me check Zoom. Like there, a more, I think, sane approach rather than like arbitrary sharding would be to split like on the boundaries of the Patricia tree, or like whatever tree we have at that point, in which case you obviously can easily prove new roots, because they will be combination of the of some sort of old roots.
I think that splitting on like a contiguous into contiguous subsets of account IDs can work with sorted trees. So you can construct a proof in this case.
But right now we want to have the simplest way to split one shard into multiple, right? So
yeah, so
maybe
now,
now
we
let's come
don't.
back to.
We don't have challenges, so we can use an approach which doesn't work with challenges, like as Bowen proposed, generating a new state basically in the background and then split, like replacing the state root exactly at the epoch boundary. Am I correct that this is the approach you propose?
Yes. I think Alex has some question.
Okay, so what do we do here?
So yeah, so you just after that point is done, the validator in epoch t+1, they just keep applying blocks as they normally would.
But
and
you do not have the state, right? For the new shards, you have the green state, like this is the green moment, right? This is moment green. You do not have, and this is moment blue. You do not have blue state for the new shards, right?
Yes, but you can run catch up, right?
Okay, so you do suggest to run catch up.
Yes.
Okay, yeah.
Yeah, I thought you were talking about other the validator in epoch t+2, which so they would still think that. Well, let's say this is a more general case, right? Let's say you have multiple shards. So people in validator for that shard in epoch t+2, they would still sync the original state at the beginning of epoch t+1,
yeah,
and then they would run the same. Yeah, they would run the same procedure. Basically, they would still need to keep the.
Yes.
Actually, they don't need to run the exactly same. They don't need to keep the old state after they construct the new state, right? Because they don't actually need to validate the. They don't need to.
Well, they sort of do because all the they still need to validate all the consecutive blocks. Like if you do state sync as from here, you still apply the entire epoch, right? You still need to be able.
Yes,
to
but they do. Do they actually need to okay, I guess yeah.
I think it would be easier for them to validate because you can use the same code.
Yes.
Yeah.
But then the guys in t+3.
So at least in terms of code complexity, it would be beneficial for them to do exactly the same as the current validation.
That's fair.
Yeah, and the guys in t+3, they just synchronize, like from their perspective, like effectively t+1 is considered to be a single shard epoch, t+2 is two shards.
Yes.
So t+3, there's nothing special. They just sync whatever shard they need.
Yes, there's nothing special. Yeah. Like in every epoch, there's only there's only the number of shards don't change within an epoch. So
yes, cool.
Just a quick question: would it be simpler to split this migration into two steps? Like in the first step, you change a state, but you only reorder the data in such a way that the data is still a single shard, but all the data of all accounts is consistent. I mean, within, it's not split all around, it's prefixed. All the data would be basically essentially prefixed by the account ID. So it's not split around, and that would help in the future to just keep the data in one, of all accounts in one continuous chunks. Wouldn't that be a better approach to do it that way first before we move to multiple shards?
I think it's more, I think if we want to get to multiple shards more quickly, then we don't want to reorganize the state. So we eventually want to have a state represented in such a way that all state that corresponds to a single account is grouped together, but it's a different change. And if we want to do so, this is kind of quick resharding change. We are just separating one account. We are not doing proper sharding with the automatic resharding and such, but later we will want to have this, and we will want to have the state of a single account all in the same place for more efficient
My
sharding.
question is that just separate. I mean, my question is basically, wouldn't separating the Aurora account just make it more complicated to do the proper sharding in the future? Wouldn't?
For now, the different parts of account are separated, but we can change it before we implement proper sharding.
Yeah, I don't think it makes it necessarily more complex. It's like a parallel change.
And then it should be fine. Then, if you think it's not going to make it more complicated in the future to do the migration to the proper version, if you think it's not going to be more complicated.
I think it's not going to make it much more complicated. So if we change the organization of the state, we can do it with 2 shards just because the split by accounts, we can apply any such change to each of the shards. So it doesn't matter.
I mean, if it was easy to do this change at once, where you just do it for all accounts that you split, then you would have, I mean, if you do it right now, then you would only have to do it once, that you split the state and move it around.
It doesn't matter, because what we would need to do, we would implement the code, but once we have the code, we can, it doesn't matter whether we run it on 1 shard or 2 shard or 100 shards, because it's the same code.
Yeah.
Okay, then should be fine then.
Yeah, also that change is not very simple. It's going to be quite involved if we were to do it. Okay, yeah, anyone else has other questions or concerns? Let's see what's in the chat. Okay, okay, looks like no. Yeah, I think we're also running out of time, so